Hello, everyone. Good morning, good afternoon, wherever you are. I'm Geraldine Cazzo, a Senior Cloud Solution Architect in the Data and AI space, and I'm happy to be here with you today. And I have my colleague, Srini, joining us too.
Hi, Srini Lavala, Cloud Solution Architect, and currently I'm a technical specialist. We both help customers to architect and implement solutions in the cloud, and we both have deeper expertise in Cosmos DB and also PostgreSQL. We're here to walk you through convert single node to multi-node using distributed PostgreSQL. Jerry?
Thank you, Srini. And now I'd also like to introduce our moderator, Rajneesh. He's not on here, but he will be manning the chats. So please make this session an interactive session. Please say hello to him. And if you have any questions, post it in the chat, and then he'll be able to answer it or he'll bring it to our attention. So please make this an interactive session and please say hello to Rajneesh. If you have not been on a Learn Live session earlier, and if this is the first one you're going through, please follow it at https://aka.ms/learnlive 2023-0906A. We follow the module that is available for you at learn.microsoft@Microsoft. And you can either practice with us and follow along with us with the exercises, or you can do it in your own time. But let's make this interactive. And if you have any questions, please do post it in the chat.
Yeah, I would recommend to, yeah,
Go ahead.
I would recommend to practice here. Otherwise, no one will explain if you run into issues, right? So we do have hour and a half, and then we should be able to get through everything, and then we are here to answer any of your questions. Jerry?
Yeah. Thank you. So before we go into the topic of the day, we would just want to talk a little bit about Azure Cosmos DB for PostgreSQL. As you know, Azure Cosmos DB for PostgreSQL is a fully managed PaaS service, and it's built on the open source PostgreSQL. If you've been to our earlier sessions, you know a little about it, that it's a distributed database, and it's highly scalable, especially for apps, current apps that need high scalability. They need the ability to be able to scale from a small set to a huger data set, right? So in a situation like that, you want to go for Cosmos DB for PostgreSQL. You can also start, like I said, with a single node, so you don't have to right off the bat have multiple nodes if you are starting small, and then your business can grow. So it allows you to scale seamlessly across multiple nodes as your business grows. So you don't have to initially start off, but as you go forward, it allows you to do that. And you have this is especially useful when you're using real-time operational analytical apps, because it has high throughput. Any application that requires high throughput, and you use it for high throughput transactional applications. So what we're going to cover today in this session, the learning modules are: first, you'll be able to understand what is a single node, why do I need a single node, when do I use a single node, and then how to create the single node in Azure Cosmos DB for PostgreSQL. You'll also learn the differences between the single node and multiple nodes when you're distributing it across, especially in terms of architecture and schema. Then you're also going to identify changes to upgrade. How do you upgrade from a single node to multiple node and distribute your data across the nodes? And finally, you're going to be able to scale the database and distribute the database across all these multiple nodes. And together, Srini and I are going to walk you through a scenario and an exercise where we're going to be able to better explain these concepts. So in this scenario, we have the worldwide importers, which is a wholesale novelty goods importer and distributor, and they're operating in the San Francisco Bay Area. Now they're local, very few stores, the wholesale stores, and so now they are also thinking of expanding it. If it works well, they're going to expand it not only within San Francisco and USA, but they also want to convert it into an international importer and distributing operating system. And as I've said here, they do store goods. And as you know, whenever any goods are there in a wholesale store, or if you're distributing, you have to make sure that the products don't go bad, they don't melt, depending on what the products are. So they need a particular temperature, humidity, and a certain consistent environment. And so for that, the worldwide importers are using sensors. So they have sensors in their warehouses, and they have sensors also in the delivery trucks to be able to maintain it, so that if anything goes wrong, they can be alerted and then take action. They're also looking to expand their business. Like I said, right now they are local, and if it goes well, they want to expand their business, and they think that they will be able to expand their business. That when they expand it, they want to be able, when the customers grow and when during its shopping season, they want it to expand seamlessly. They do not want their applications to have any downtime, but they want it to be a seamless business growth, right? So seamlessly, they want their application to scale. And again, like I said, they want to start small. They do not want to over provision because that costs money. So they want to start small, but then be able to expand out. So in this case, we suggested that the good use case for Azure Cosmos DB for PostgreSQL, this is a good use case because they not only can start small with a single node, but when their business grows, then they can start increasing it, scaling out without having to worry about the applications being down. So Azure Cosmos DB for PostgreSQL, as I said, is a single node database, right? So let's go to Srini and see, Srini, why do do they want to use the single node database? Is our suggestion to them right, with keeping in mind their use case?
Yeah, as a worldwide importer, they just wanted to start the application or build the application, test it, and see how popular it would become. So, and also it has a huge growth, exponential growth. Soon after deploying to many warehouses and then adding more trucks, right? So it's a huge potential for a growth. So at this time, I mean, you have a lot of relational databases where which you can vertically scale, but you cannot scale horizontally. That means adding more servers is not possible. So that is why we are suggesting Cosmos DB for PostgreSQL, and you can start small, but you don't have to change anything. You don't have to disrupt your production workloads. You can add more servers, grow horizontally. That means, yeah, no downtime when you're running the application, and then it improves the performance also. So yeah,
So
even with
when
single
would you
node,
use a single node, Srini? When would you suggest? What are the use cases you would give to suggest them they use a single node?
single node is basically used for starting or testing application, building applications, and then small production workloads, right? So as you are deploying it to one facility with 10 trucks, it's like a small workloads, right? And everything is working fine, and then yeah, now I wanted to add 100 facilities with thousands of trucks. That's when you expand and go into multi-node. So you start with small, and then you have options to expand based on your um, adoption.
So now that they have a single node, let's say we've sprung up a single node for them, How do they know when to move to a multi-node?
Yeah, as we are talking about one facility with the 10 trucks, and then now we are adding hundreds of facilities and then thousands of trucks. And then when they're trying to use that, it is going to, application will become slower, and the performance wise, it degrade the performance. So at that time, okay, it is telling you that, okay, this is the time you can go to multi-node.
Okay, so do you want to go into the worldwide importer schema that we discussed, where with their technical team to talk about what is their schema and how we can use it, maybe in the same form or whether we need to change it later. So can you go through a little bit and tell us what is their schema and their structure like?
Okay, let's talk about this schema. Basically, they're using sensor, right? So on devices. So the devices, it could be a warehouse, monitor, or a truck, and and those sensors are built to read the humidity and temperature, right? So in that case, so they have a simple schema with the device types. So they do have two types. One is warehouse, and the other one is a truck. So so we have a table. They created device types, and then you have to list all the devices, right? So we created another table called device table with the device type ID is linked. So whether the device is a warehouse or it is a truck. So that's how there is a foreign key dependency saying, okay, this is these two tables are tied together. And now sensor sends the data every minute. So we created another table called events table where it reads the data, humidity, temperatures, and from warehouse device and also truck device. So that way we have the third table where sensor keeps all the data using device ID and the readings, right? So those totally we have three tables. One is the device types, is connected with the device table with a foreign key. And then the third one is event table tied with the device table using a device ID. So those are the three tables we start with.
So it is
And
similar to
yeah,
what they have on-prem or, when they do a single node, right? That's how you do it. It's not distributed. It's just three tables, and you have the device types that have the two devices, like you
right.
said, and then the primary key that uh, is referenced to in the device table with the device type ID. And then
Hmm.
in the device, you have the primary key, which then again is a foreign key in the events table. So can they have it the same way even in the single node? Do they need, let's say this is on-prem, so do they need to change it, or can they keep it this way also,
The, yeah,
when they're using a
yeah,
single node?
yeah. Yeah, they can just keep it as is, right? Even if you have an existing application running on-premise and if you wanted to move to cloud, you can just keep the same schema and then run it in single node of PostgreSQL, where you don't need any changes. And as you're saying, it's similar as you're seeing here. It's a regular schema for any relational database.
Yeah, so some things that you need to keep in mind when you're talking about the multi-node, right? When you consider it, when would you consider it? It's when you've increased your data and now it's hitting the limit. You can't scale vertically. All your resources are maxed out, but you need more workload is coming in. You need more processing power. And so maybe that is one reason why you need to scale horizontally. Um, Another reason could be because you're trying to aggregate data, and your queries are now taking a longer time because you have more data in there. So when you have more data and your queries are
Yeah.
taking longer, you're not getting your data back in time to make the required changes, right? Or to rectify the situation. And especially in the case of worldwide importers, if you're talking about products like chili chocolates is one of their main products, and if the temperature and the humidity is not right, then you're going to have melted chocolates by the time you reach the destination, right? So in a
Yeah.
situation like this, when you increase the number of devices or you increase the number of warehouses
Aggregate
or
queries.
trucks or whatever it is, you need more.
Hmm. Yes.
So
Now we
go
went
ahead,
through
Srini.
this the description of the schema and how we start with a single node and then the reasons and the timing when you move to multi-node. So let's get on to the action. Why don't we just start
The exercise.
the exercise to see how to provision Cosmos DB for PostgreSQL in Azure. So this is the first step.
So
Let
Srini,
the
you can
first
take it.
exercise. Yeah. And basically at this point where I will show actually this is where the first step is to look for your service, right? You can just say
Yeah.
PostgreSQL. So first step is you have to log into Azure if you have not done that already. So I'm trying to. Looks like it is taking time. Okay. It looks like the screen is frozen somehow. Let's. Uh, uh, Jerry, let me try one more time. Okay, let's. I'll show how to log in from the beginning,
Portal.
right? Portal.azure.com. You log in here, and this is where you actually see all the services in Azure. Mm, Hmm. Jerry, you wanna
Take
try
over.
yours? It looks like it's
Yeah,
little.
I can
Yeah,
do that.
take over and
Okay.
yeah, looks like
So
it's
let's go to the
taking
exercise.
a little slower here.
So I'm going to all resources. I'm going to close this out. Can you see? Yeah. So now, like Srini said, we're going to provision a single node. And those of you who were on the previous call, you would know because we walked through the exercise of also creating a single node there. But now I'm going to walk you through how it's created. Again, like I said, we follow everything that's there in the exercise. As Srini mentioned, we have these three tables that we are going to create on that Cosmos DB single node. So in order to create that, I'm going to click and create a resource and look for Azure Cosmos DB for PostgreSQL. Okay, I'm going to say create, create new. I'm just going to say learn live scaling demo. So I won't have the problem of having a duplicate. Okay, and I'm just going to take, let's go here. And now I'm going to take another name because I don't want to have the same cluster name. So learning, but you can copy what's there in the exercise. Learning live cluster. Oh, learn live. I'm just going to put learn live. Okay. And I'll walk you through that, but let me just quickly walk you through what's here. It's the same thing. It says enter the resource group, enter the cluster name, the location, then enter the actual nodes that you're going to have, which you want to scale to, and then you specify, you can review and create, and then you can specify the network, or I'm going to just do it at the same time and create the network too. So what I'm doing here is using whatever is the PostgreSQL version out there. Let's enter the password. Let me see if I got that. Okay, Control C. Okay, now I want to do the networking. Like I said, you can do the network piece later, but I'm just going to do it now. And you want to allow the public access from all the other Azure services to this cluster that is within the network. And then I'm also going to add my IP client address to it. Now let's just say, wait, so did I put in the node? Yeah, let me go in here and change the node. So let's go configure it. Wait, did it say the cluster name already existed? I need to go back and check that. Um, so we have a single node. It says four.
And also, can you change that to 4 cores in the config?
I changed. I'm doing that. Yeah. So save. And the cluster name must,
So yeah,
oh,
4 cores
yes.
should be good. Yeah.
Yeah. Okay. So just let's review it. It says everything is fine. Let's create. So while this is creating, Srini, I do not have one that's already ready to run the SQL, the create statements on it. Do you have one that's already created that you can now take over and show the create statements? Srini?
Yeah, I think yeah, it's coming up now.
Okay.
Yeah.
If you already have one that already exists, can you just then create the tables and stuff in it?
Yeah, I
Thank
can show it to you in a minute. Yeah, just a second. It's pulling up.
Okay, so Srini is going to now take over the next piece of
So the
the
one I have
demo.
created already, so I can bring it
Yeah.
up and then walk you through. Yeah. Post-COVID era, the internet is the god, and then we have to depend on internet. Looks like it's yeah, it's back up now. So the basically
That's good.
after Jerry created the service, right? So provisioning PostgreSQL service, so you can actually go to that resource and then see this here, and this will show you the information what you have, and at this time looks like this is not the right one. So this one, live demo. So first thing you have to do is how to connect to the PostgreSQL, right? So that's the first step we're going to do. So for that, we will have to check this connection string. That's where you have these um, the connection strings for connecting to PostgreSQL, and also you option to start the PSQL, right? So, and at this point, it's on the right, on the top bar next to the search. there is a cloud shell where you could run the commands and then connect to pSQL. So when you click on that, you will have an option to select bash versus PowerShell. So you will have to select bash. Okay. So it might ask you to create a storage account. Whatever the data you commands you're typing here, it stores that information. For that, it requires a storage account. So it's not going to cost a lot. So it's a small amount, less than $1. Small means that much. So here, when you log into Bash, this is where you copy the again looking at connection string pSQL. So copy that and um, paste. You can do paste like this or Control Shift V to copy that. Right. So right here you will have to change the password because this will not save that information. So giving more security so that you can put your password here. So very intuitive, right? So now I'm connected to Citus. This is an open source version of distributed PostgreSQL, and that's why we're calling it as Citus. So that means it's a distributed SQL. And now let's go through the exercise of creating the tables, right? We talked about 3 tables, and then let's see how we can create them. And then right here,
So
simple,
while
you
Srini
have
is
an
doing
option to
that,
copy, and then with this, yeah, yeah. I'm just saying, when you are copying a code to create all these 3 tables. So yeah, so okay, looks like which one is this? I thought I have. So run that command and then it is going to create tables. Go ahead, Jerry. So looks like I thought this is okay. Yeah, please go ahead and
oh,
talk, and then I'll switch
it
over to the
already
other one,
exists.
the one I just created.
Okay,
Yeah.
so no, but I was just going to
So I'll
say,
go ahead
Srini,
and
that
change that to the different one. Yeah.
you could do it either using the bash, or you can use ADS, or you can use PG admin, whatever is your choice. You can use to create these tables or to run the SQL.
So I'm going ahead and connecting to the new one. The names were so similar, right? And the one I actually tried before, and that's where
Yeah.
I'm connected to before.
And that's the reason why I
Okay.
used something completely different. Otherwise, I would
What's
have the
going
same
on?
issue.
Okay. I guess this. Why is it taking a longer time?
Mine is still provisioning. Others I could have taken it over, but it's still provisioning.
Okay. Okay. So this should work now. So ask us if you have any questions, okay? And while we're provisioning here,
So
maybe it's
while
still provisioning.
uh,
Why is it not? Yeah,
while Srini is working on that, Srini, while you're getting that up and running, maybe I'll go to the next
yeah.
piece of the slide, and we'll come back and do the exercise though.
Okay.
Um, so
Yeah.
I'm going to
Mm-hmm.
take over and share screen.
Okay.
Okay.
Sure.
So once that's Srini can get that provisioned, or I have mine provisioned, then we'll come back and do the exercise. So in the meantime, once we have the single node provision, we need to understand what the architecture is, right? What happens when we go from a single node to multi node? Does the schema remain the same? Do I need to have any considerations? Do I need to follow anything? And also I want to understand, like, what does it mean to have a single node in a cluster and have this data on it? And then again, I want to understand, okay, when I move to the multiple node, what should the architecture be? Will it be the same? Will it be different? Because we are talking about a single node in a cluster. So what does a single node in a cluster mean? So when we talk about a single node in a cluster, both the coordinator node and the worker node. So there are two nodes actually when you're talking about a Cosmos DB for PostgreSQL cluster. There are two nodes. One is the coordinator node, and the other is the worker node. So the worker node is the node that actually does the work, where all the work is done. It's the node where the data is stored, right? And it's the node that processes your queries. Whereas the coordinator node has like local tables which holds your metadata, and the coordinator node is the one that coordinates across all the worker nodes. It's the one that determines how to send the queries out, to which worker nodes the queries need to go. So that's what the coordinator node does. It controls and coordinates everything that goes on, all the processes and activities that happen at the worker node level. So once you go from the single node cluster, as you can see, you have the same node. It's one physical node, but both the coordinator node and the worker node now exist on that same single node. So the coordinator node and worker node are shared on that single node. And you, like Srini mentioned earlier, the reason you would use a single node cluster is when you have small production databases, when you have the test environments that you just want to spin up and test something, or when you want development. So in this case, for worldwide imports, they want to test it out because they've decided to go with Cosmos DB for PostgreSQL, and at the same time, they know that their initial business they're going to start up with a small business, and if it succeeds, then they want it to expand. They do know that it will expand, but they want to give it a shot first, and that's the reason why we are creating the single node cluster. And then once you have a single node
Okay,
cluster,
Jerry.
and once you have the single node cluster, and then it increases, the workload increases. What can we do, Srini? Srini, are you ready to demo, or shall we continue with this?
Yeah, exercise. Let me walk you through this. And yeah, basically, we ran through this and then created the tables, right? So that and this is the command to list the tables /dt, and it shows the tables we created, and as talking about indexing, right? There is a special indexing um, created for JSONB. Can you explain what GIN index is, Jerry?
Yeah, so the gin index. So when you have a JSON-B or you have a data type which is itemized, and what I mean by itemized is you have name value pairs, and then you have one item within the other. For example, I have name. Name is the object, and within name I have first name, last name, middle name, whatever you want to say, right? So there are multiple items within an item, and so when you have something like that, you just cannot use a B-tree index, because then you won't be able to search on particular words or columns or values that you want in this whole JSON-B structure. So when you have a column like that, you want to go for a gin index, because the B-tree index will not work. So, and there's much more about the G-tree index and the gin index and how it works, how different it is from the B3. But just remember this, is that you can have an index where you have multiple, the value of one column that exists in multiple areas, and that's how it stores the index. So when you want to do searches and stuff like that, like a full search and stuff like that, you want to use a gin index.
So to improve the performance of event tables, we are creating a gin index on payload. So this is the command to create the index, and then I'll go ahead and run that here. And again, Control Shift V will give you that, and then it'll create the index. And if you want to see where the index is, if you can type /D for the table, and then give the table name, it'll give you the one we just created, right? So that's the one gin index. Okay, so that's how you create the index. And now these are the actual distributed tables. So the Citus stores all the distributed tables in information inside a Citus tables table. So basically, let's verify if we have any data there, instead of just believing me, right? So try it. So no data is here. No table is created as a distributed table at this point. So we just created 3 normal tables what a relational database uses. So now let's load the data, right? So we are loading the data for what are the types? We are creating 2 types, basically delivery truck and then warehouse. So that is, we're populating the data into device types. So let's go ahead and complete that. So we got the tables. We created 2 rows there, and then copy. Now we'll create. So we are creating devices close to 100, I think. So we'll just run that and then create the device data in it. And actually, we're creating a procedure to create randomized devices. So we just created a stored procedure. Now we are running that stored procedure to create 1,000 devices. So that's what we're doing here. And then it'll create 1,000 devices there. And basically here next, create another procedure to populate sensor data. So actually, we are providing 42 as the device ID for us, to make sure we have that device ID saved. So here, this is the procedure to populate sensor data, and this is the stored procedure, right? And now we are running another procedure to run the population of data. So this is another procedure. You can just look at the code at your leisure time. Now we are creating 10,000 events. That means storing the temperature and humidity data. So running the store procedure for 10,000 events. So now I think we're almost done populating the data. And now let's look at the count, check the count on each table. So we are counting the records in each table. So basically, 1, 2, 1,000 devices, and then 10,000 events, right? So that's how you actually um, populate the data. So Jerry, you want to cover the querying the data? How you? It's
Go
regular
ahead, you
SQL, right?
continue with it, Srini. You can go ahead.
Okay. Yeah, just running the query. Basically, I wanted to find out how many events has this temperature between 6 and 70, and then humidity between 60 and 70, and then the temperature. So basically it's similar to same SQL running that. So we can go ahead and run that here. So it'll give you a lot, and similar to another standard SQL data. So you can go page by page by doing the scrolling down or hitting a space, right? And then you can quit with the queue. And now I want to find out the devices having issues, right? So run this command and then trying to get get the count of the problems each device have, right? So it'll tell you the count device ID 42 has more problems showing like 2779, right? So that's how you kind of run the query to figure that out. And now um, so you can just run using just the device ID, right? So when you since you know the device ID, I just want to get more details of these errors. So it'll tell you, okay, it's a high humidity levels that much, and then um, the high temperatures is like 526. So that's you get more details after finding what device is causing the problems or the problem device. So that's how you run, and yeah, again you can run more events. For example, if you can add more events, and then um, using the command, so it'll create 50,000 events. See, it's working fast, even it is a single node. But when you're running aggregation, that's where you see the performance issues. I guess that covers the population of data and then how you can query the data in single node. Jerry,
Yes, so as Srini said, right,
one
we
nine.
have the single node and we were just simulating the data. So the first thing he did was create the devices, the device types actually, and then we went and created a number of devices which have sensors on them, and then we created the events because, like we said earlier, Worldwide Import said that the sensors release data or send out events once a minute. So that's a lot of data that's coming out. Yes, it's a single node, so we created only I think 50,000 events. But if that scales out, then can you imagine the amount of data you have, the amount of data that's coming in, and then the amount of data that needs to be aggregated. So what he did was just go in, aggregate it, find out which one had the most issues with it, like why were there so many events, and then he was able to determine that the device 42 was the one that needed more attention, and then you go into the details to see what device 42 is doing. So thank you, Srini, for that. Now I'll just come back to the PowerPoint presentation. And back to you. I'm giving it back to you, Srini. So, what is the distributed architecture like? We told them how to use single node. We show them how to create it, but now their queries are not doing good. They're not performing well as they're hitting all the resource thresholds like the CPU and the RAM and stuff like that. So, what do you suggest, Srini?
So that's what we actually planned for, and yeah, can you hear me? Yeah. That's what we planned for, right? So how do we distribute the data to scale horizontally? So for example, you have the data, um, the data in event table. This is the huge table, right? So each one has its own. If you can go back to the previous slide, I just want to show how we could um,
Yeah.
uh, actually aggregate the data based on the device type, and then the distribution happens by chunking this table into small shards or small partial tables. That's what and the distributed architecture come into picture. So when we wanted to distribute this table into a different shards or different nodes, you chunk the data as a partial data sets and then spread them along different buckets, basically. So that's how the distribution works.
So basically, the distributed architecture takes your table, and I won't call it partition because partition is totally different, but it's similar. It divides your data into smaller and groups it together, kind of smaller groups based on how you want to do it, and then it creates it like smaller tables, and then it is able to now either distribute that across the nodes or distribute it within the same node, right? And by default there are like 32 shards. That is the default number of shards that is in a node, and then you can have it across multiple nodes too. But the key point is to know that you have the ability to divide your data and chunk it into smaller pieces.
That's how the horizontal scaling happens, and then at this point you can add more nodes when the volume is growing, and even if you wanted to have better performance. So each node comes with a higher CPU or compute power, and also memory, and also storage. So that's how you adding more fuel to run the application performant. So as Jerry said, it's try to maintain that default 32 shards, and then it'll kind of distribute into different worker nodes. And if it is even, you can have the same shards in single node itself, but to scale horizontally, you add more worker nodes.
And also you have to make sure that you know what your queries are, because you want it to be able to use it to be able to spread across all these nodes, return your data fast. So you have to be able to distribute it correctly or make it into the right shards based upon your distribution key, which we will talk about later. This is what is the architecture of the multi-node, where you have the coordinator node, you have two worker nodes, and then you have, like I said earlier, all the actual processing that takes place on the worker nodes. So what's the difference between what you're seeing here and what we saw in a single node?
Yeah, the difference, you see that shards are distributed along the nodes, and that's where the coordinator node kind of sends it actually receives the query, and then figure out if it needs to send the query to a specific worker node. For example, if you wanted to get the data for the basically device type 42, if the 42 lives inside the shard 4, and then it goes to that worker node 1. So that's how the actually coordinator node controls the flow and then gets the data back and then present to the query.
Yeah, and the coordinator node is a single node on its own, and then you have the worker nodes, which are independent, as opposed to both having the coordinator node and the worker nodes on the same single node, right? That's another difference between the multi-node architecture and the single node architecture. Another thing also you want to know, like Srini said, if you want one, the coordinator knows to go to one. So it goes, gets one, it's very fast, it knows where it is. But if it has to go, if you do a select star from table, guess what it's going to do? It's going to span across all the nodes to bring back all the data. So that is going to do a scan, and everyone who's worked with relational databases knows that scans degrade performance. So that's why it's key for you to understand what your queries are, how you're going to run it, and then consider how to distribute it. Okay, so exercise 2, I'm going to show you and demo what the exercise 2 is. So let me go to the exercise. And I've already created these nodes. So both the nodes exist. You have one coordinator node and one worker node. So let me go to the right cluster to see what it is. Okay, this is the cluster. So let's go to scale. Okay, so we have one node. It's a coordinator node which has 4 vCore, 16 gig RAM, and 512 is the node the storage, right? So now let's go back to the node. I'm not going to start adding the nodes just yet, because what I want to show you is, and this is everyone's, even the tech group at Worldwide Imports, the first question they had is, okay, when I increase the nodes, what happens? Is there any performance degradation on my app? You told me that it's not going to have maintenance problems, right? It's not going, I'm not going to have to bring down my application. But then what about performance? Is it going to affect the performance? So let's see what we can do. What we're going to use right now is PG Bench. PG Bench is a tool that will allow you to benchmark and to check what the server performance is, right? So in order to do that, we're going to run a SQL query and store it in a file, and then run that file in a loop to see what's happening and when it's running, as well as when we are adding the nodes. So now I'm just going to quickly go through the SQL here, not too much, but just to tell you, we're trying to figure out and group the devices and the count based on certain parameters. So I'm only going with the first one, where you're looking for the humidity that's less than 60. And that's what you're going to say is low humidity. Now, in the same way, you're going to determine the thresholds for high humidity, low temperature, high temperature. So this is what the query is doing. It's going to aggregate it, or your devices, to see how many events fall into these thresholds, right? So I'm going to quickly copy it. Oh, first, let me go back here before
It's,
we do that. Yeah.
it's actually simulating the client or production workloads and then trying to show that it will not impact the production workloads when you add extra nodes.
That's right. So before I go there, I'm going back here. Let's go to the connection string. I'm going to get the pSQL, put it in here. I think it's already there on top.
It's
Yeah,
PG
it's the same
URL,
one.
Jerry.
Yeah.
PG URL, not the pSQL.
No, no, I'm just doing the select statements, Rini.
Oh, okay.
Yeah. Go back. Go to the cloud. Change it to bash. Confirm. I've already got my reconnect. Okay.
Did you populate the data there? Or?
I did.
Okay.
Okay. Now paste it. I've run that. I'm going back to copy this. Go back here. Paste it. Run it. Right? So this is just showing you the data and what is available when you run that select query. So now let me go back here and put that into the outliers. So I'm going to do quit. Let's go back to the exercise, see what it says. Now the same query, I'm going to store it in the outliers.sql so that when we, and I'm going to run it so that when we actually increase the nodes, I want to see whether the latency or the transactions per minute, what happens, whether it increases, it decreases, or if it kind of remains the same. Let's go back. And, oh, /q. Yeah, so come out. Going to put it in the outliers SQL. Okay. Now I want to create this variable, and this variable is going to store the connection. But the connection here, when you're running to get PSQL, you pick up the PSQL connection string. But in this case, where I'm trying to put it in a variable and then run it through the PG bench, I need to now pick up, let's go back to connection strings, and get the PostgreSQL connection URL. Okay, let's go back here, and I've copied it from there. Let's just paste this here. Test, Control V.
You want to zoom up a little bit? Yeah, you can see it.
Sorry, Srini?
You can probably zoom up. They won't be able to
Zoom
see
this.
that much.
Yeah. Okay, so, okay, you can see it here. Let me go back. Okay, here you should be able to see it better.
Yeah.
I'm going to paste it here. So this is just exporting the export PG URL is the variable, creating a variable and exporting it to be ready. What happened? Oh no, sorry. How did it go to PowerShell?
The default, I guess it takes that.
No, I ran the Citus in there, so it went back when I quit. Anyway, let me, actually, I need to go back and create the outliers again. So copy this, go back, paste it here. Okay, got that. Go back here. Copy the export. Now tell me if it's visible, Srini, when I run it from here.
Yeah, it's visible.
This is visible. So yeah. So it's the same thing. Now I'm just exporting it. It's exported. Okay. And now we're going to actually run the PG bench with this SQL script. And there are a few things you need to know when you're using PG bench. One is the clients. How many clients do you want to simulate, which is the -C. That's the 64. Then how many threads do you want? I want 64 threads for the 64 clients that are there. What is the time, right? How long do you want it to run? And then if you're well versed with PostgreSQL, you know what the vacuum is. I'm not going to get into what it is right now, but -n means I'm not going to use the vacuum. P is how long, like how often should it give you the report or progress with the report in seconds. And -f is the file that you're going to use, that you're going to run. So let's copy this, put it back here, and PG bench is going to run. Now let's watch it for a little bit. As you can see, it is showing you the transactions per second, the latency, and you get all this. And while it's running through, I'm going to now actually go in and add the nodes. And then we come back to see if it was nearly the same or if it changed. So let's go back to here. Let me go to scale while that's running. Let's going to minimize this a little bit. As you can see, we still have the coordinator node as single. I'm going to convert it into 2 nodes with 4. Okay, let me just go back to single. I just want to show you something. When you see single node, as you can see, after the nodes, there's availability zone. There is no option for you to change what the coordinator node is, right? It's just 1. Now let's go back to 2 nodes. And as you can see, it has changed. So I'm going to do 32. I'm going to do 512. I'm going to do the same here for row 16 and 512. Now let me say save.
We're not changing the coordinator configuration, right?
No, we're keeping it as default for
Okay.
now.
Yes.
So which is good. So let me talk about that, Srini. The good point you mentioned is
Sure.
the coordinator node, right? When you set
Hmm.
up with a single node, how is there anything we need to keep in mind
Yeah,
when
basically, we should not force the restart. So if you change the coordinator node configuration, it will start, it will require a restart. So that kind of causes the disruption in production. So that's why we don't change anything in the coordinator node, and you can add more nodes, uh, worker
yeah,
nodes.
as you can see, the coordinator node has 4 cores, 16 MB. If I had done 2 cores, 2 nodes, I would have been able to scale out. But if it was less than the max, then what we would need to do is have a downtime, because then it's scaling up the coordinator node, so there will be downtime. So your application will need to restart, right? So for that reason, you have to make sure that when you're setting up the single node initially, it has the appropriate or the right number of cores and memory. So while this is deploying, as you can see, there's not much difference. The TPS still keeps remaining the same as before, and the latency also is the same. There's not much change, so performance is not going to be affected with this. So that's what is this exercise. We want to show you that your performance is not going to be affected. You're not going to have any downtime. Your applications with PG Benches, the application that's running, is still going to run without any issues. So I've added the nodes,
The last step,
and yeah, and now I'll show you this also. So like Srini had said, right? So you have to get the coordinator compute nodes in the storage correct when you're doing a single node, because if you don't, then it's going to have downtime. So I have another one that I have just created and for this purpose. So while that's being deployed, let me go back here and go to the add node uh, test cluster. Okay, and let me show you what the scale is. So it's 1 node, as you can see, and it's 2 vCores and 8 GB RAM, right? So now I say I want to increase it. I want to make it 2 nodes. But as you see, as soon as you have 2 nodes, it's changing the worker node. It also changes the coordinator node. From 2, it's becoming 4. Now let's see what happens. You see what it says? You selected to change the configuration for the cluster. When you select that, make it higher, then some changes require the node restart, which is, in this case, the node needs to be restarted. I'm not going to continue because I don't want to restart it, but that's just to show you that if you do not get it right and if you use the bare minimum, then when you want to scale, it's not going to scale out. So let's go back to the exercise. Okay. So this is basically what it does. If you had to do it through PG Bench and I really went ahead with it, you would see it terminating and it will show you the error message, which I'm not going into right now because I just want to show you how this is progressing. So as you can see, no difference. It's the same. So you don't have any issues at all. I'm going to control Q. Okay.
yeah, that's
Okay.
we got 30
And
more
then,
minutes. Let's
yeah.
speed up a little bit.
So yeah. So that's all there is with this exercise. And you can run the select command from the citus tables. It shows you that the data is not distributed. So the other thing you need to remember is as soon as you scale out or you add nodes, your data still is residing on that 1 node, on a single node. It's not scaling out at all. So what do you need to do? We need to do something in order for us to then be able to scale out. So that's it for this exercise. And I'm going to go back to my PowerPoint presentation and start from here. We're done with the
So
exercise. And if you have
I'll
any
start
questions,
there and
yep,
yeah. Yeah, basically the
go ahead.
table classification. So for the distribution PostgreSQL, it will have three types of tables. So basically, one is local tables, and then second one reference tables, and then the third one is the distributed tables. So Jerry, what is local table means?
So the local tables are generally the tables that reside on the coordinator node, and it has no relationship to the. Generally, you don't want it to have any relationship to the reference tables and the distributed tables. Mainly, you use it for your application metadata, or like if you have users and you want authentication, application authentication and stuff. That's where you would use a local table.
Yeah. How about reference tables?
So the reference tables. If all of you are well versed with relational databases, sometimes
Kind
we
of
call it
lookup
lookup
tables.
tables.
Yeah.
We
Yeah.
call it lookup tables, right? That's what a reference table is. You call it a reference table, you call it a lookup table. The one thing that you need to remember when you're talking about reference tables in the context of Cosmos DB for PostgreSQL is that the reference table gets created or copied on all the nodes. So every node that you have, the worker node, has the reference tables on it. And the reference tables, because it's on all the nodes, you have to make sure that the reference tables are smaller, do not have too much of data, and maybe that the data is not changing too often. So I'll give you an example, right? If you're using the device type, it has two. If you're using, for example, products, and you know you have a small store and you have 10 products, then yeah, you can use the reference table. But if you are a big store like CVS or Market Basket or another grocery store like that, which has a lot of products, then maybe you need to then convert that lookup table into a distributed table. And that's why I wanted you to understand the difference between a reference table in the normal, when you're talking about normal relational databases, and a reference table here. So a reference table here needs to be small. It is like a lookup table, and you have to have kind of static data. So there are things that you need to keep in mind, which we will be talking about later when we talk about the reference tables. What about the distributed tables, Srini?
Yeah, distributed tables are the largest tables in the database, and that's where kind of you wanted to distribute the data among the shards and then among the nodes. So this is where you have to be very careful to choose the right distribution key for these tables. So distribution tables are the critical piece of tables for distributing the data across the nodes and horizontally scale your relational tables.
And the other thing also that you need to keep in mind, when the local table is stored in the coordinator node, the reference table is stored, on every node on where the shards are, and the distributed table again is across all the shards.
Yeah, basically, reference table data is being copied on each shard. So that's why you have to make sure it should be a smaller table, small set of data, and then obviously the distributed table is the data is being chunked into different nodes and shards.
Yes, so as you can see, the reference table is device type is on every worker node. The metadata table is a local table. The user authentication is local, and so it's in the coordinator. And then you have the distributed tables, which are the tables that you have. The two distributed tables are the device and the events, and they are distributed across the worker node. So that's how the tables are stored in a Cosmos DB for PostgreSQL cluster. Now, reference tables, I've already touched upon this, but we'll go through this pretty quickly. The reference table versus a distributed table. So how do you choose whether you should have it as a reference table or you should have it as a distributed table? Like I said, it depends on your data. Srini also said the same thing. If you have more data, Make sure that you make it a distributed table, because you're going to duplicate this data across every node and it's going to take up a lot of space. One thing. The second thing, also, it's going to interfere with the query processing. So, how often do you use this data? Keep in mind, if I'm using it very often, I mean, if it's huge amounts, then maybe I should distribute it. What are the performance implications? The more data you have in the reference table, the more it needs to go to the distributed table, because otherwise it will cause performance issues. The data needs to be, you have to figure out, okay, should I distribute it or should I duplicate the data? Again, like I said, it all depends upon the amount of data that you have. So in worldwide importers cases, because you have so many devices and the devices are growing significantly, it is converted and stored as distributed table. But if you had like maybe 10 to 15 devices, which were, throwing out a lot of events, then you would still have it as a reference table.
Yeah, I would like to answer a question Avanish asked. He was trying to add, for example, if I added the worker nodes, I distributed the data, and then if I add another node, what happens? Is it going to distribute the data automatically, or is it is it going to move the data? So that is the beauty of PostgreSQL distribution version. So it can actually automatically distribute the data into the new node and readjust the data among all the worker nodes. And it does not require any downtime. So that's what I would like to kind of explain to the question. Go ahead,
Yeah.
Jerry.
So, yeah, a great point and great question, whoever asked the question. But so Srini, back to Srini's point is that you can add, when you're creating it for the first time, it does it automatically. Once you've set it up, it automatically, any more data that comes through automatically gets distributed. It's only when you're doing it for the first time or converting it from a single to a distributed, only that's the time when you need to recreate it. Okay. And like we said, now because we were talking about reference keys and lookup, so there are foreign keys involved. So, Srini, do you want to talk a little about the foreign key implications and what they need to keep in mind?
Yeah, foreign key is basically talking about the dependency, right? When you're trying to create distribution tables, creating for that, you have to follow certain rules. So basically, you can have foreign key relationships when you're creating distribution tables. Um, you can have foreign key relationship between the two local tables or between the two reference tables, no issues. And you can have a relation between reference tables and local tables also. And see, at this point, all these are like you have the no connection between the distribution tables, right? So that is where you have to be careful when you are connecting two distributed tables. So that means you have to use the same distribution column so that it both exist in the same place. So that is where that foreign key is allowed. And now for distribution table to reference table is basically the dependency, right? Because um, the co-location we are using, so we could make sure the foreign key can be used at that time. And reference tables are allowed to have a foreign key relationship because it is a copy in each shard. So that's why it is fine. So so these are the rules, but where is not supported, that's where the connection between distributed table um, to reference. So basically, the reference table have any dependency to distribution table. The distribution table is distributed into different nodes. That's where it is not supported. And also the relationship between the local tables and distributed tables is also not supported because the data is distributed in multiple tables and then connection from local table is not possible. So those are the two places where you have to be careful. You cannot have foreign key relationship.
So the thing you need to remember is you can have the relationship from the distributed to the reference table, right? But you cannot have it from the reference table to the distributed table. So that's something you need to keep in mind.
Yeah.
Okay, so how do we choose a distributed column, right? So one of the things that you need for a distributed column when you're trying to figure out what distributed column you want, you need to look at your application and see what is the central piece of the application. Uh, let's say, for example, you want customers, right? You have a lot of customers and all your queries is customer based. You do not want to know about all the customers at the same time or simultaneously. You want to run your queries for each customer or each tenant. So that's when you would use the customer ID or the tenant ID when you're using multi-tenant applications. In our case, which is IoT, you use the device ID because all your queries are going to be run off of the device ID. If you're using a retail and it's all about a store and you only want to know about a store, then you use the store ID. And for example, if you're using, in the travel industry and you want to do hotel chains, then it'll be at the hotel chain level. So you need to know what your queries are, how they're run, and how your data is distributed, right? So, for example, in this case, the device ID, there are multiple device IDs, and the device IDs also keep spitting out events every minute. So there are a lot of events, but at the same time, if every device is going to send out an event every minute, so within 60 minutes, you're going to have 60 events. So every device ID will have 60 events. So it's not only the amount of data, the cardinality, but also the distribution of data across your column. And last but not least is that, you wanted to make sure that when you run your query can be parallelized. It can go across the nodes, collect all the data that is required, and then aggregate it in the coordinator. So you want to parallelize your queries. And that's the most important part of a distributed system. And if you have tables that are commonly queried together, which you're using together and always join them, then you want to co-locate it in the same location, just as you would do when you're doing your applications, right? You co-locate the application along with the data. In this case, we are co-locating the data sets together. So this is, Srini, do you want to talk about how do you create a distributed column? And
Yeah. Yeah, it's a basic. Yeah, it's a function you can run, and there are two ways you can run, right? If you already have data, and you don't want to have any disruption, you run that function with concurrently as the separate function to run when you have already have data. And if you are starting from scratch, then you can run create distributed table, and you provide the table name and then the column name, distribution column name. So those are the things you have to be you have to decide the column as Jerry talked about, and run concurrently in our case because we already populated the data here.
okay. So, as we said, there's a lot of things you need to know when you're changing from a non-distributed to a distributed. I'm not going over what the schema looks like. You all know by now what the schema is. So the one thing that, and I think Srini touched about this, so I'm going to go through it very fast, is that, the device type ID that, let's go back here. The device type ID that you have here is the primary key. It is the foreign key to the devices in the device table, right? So, and that's okay. The devices is going to become the reference key. But if you go to the events table, as you can see, the events table has the primary key, which is the event ID, to make it unique. But you cannot choose that as the distributed column because, as you know, every event is unique. So you have only one row for each event, and that's not the best practices. So in this case, you would need to take the device ID and distribute it on the device ID. But then how would you have, if you're taking it on the device ID, then how would you have a primary key that allows for uniqueness? So for that, we create a composite key, which is the device ID plus the event ID, right? So that's the relationship between those three distributed tables, or when you convert them into a distributed table. So, Srini, do you just quickly want to run us through what's steps to move to a distributed layout?
Yeah. A device table, basically the reference table, you can create the reference table for that. And the primary key for the event table where we have to delete the old one and add the event along with the device ID as the primary key. So that you will change that as the second step. And now you have to drop the foreign key definition before you distribute the data, and then you can populate the foreign key again at the end. And so you create a distribution table for a device table, and again the same way you can create a distribution the event table. You can you can distribute the event tables with the same command as we talked about before, and repopulate the foreign key for event table. That's this the flow you will do to complete
Okay,
the
and this is
redistribution.
how the current, once it's done, this is how you see it, where you have the primary keys. This is the same. This is a distributed table. The event is distributed. And what is not being displayed here is the device ID. So the event ID and the device ID becomes the primary key. So, and
So
now
one more
once
thing
you
is,
have the data,
yeah,
yeah, go ahead.
Jerry. Last
Yep.
thing is like you have to truncate the data in the coordinator node after you finished all the distribution. So otherwise the data remains
Exactly.
there.
Yeah. And it's the same. Now, moving existing data in use. So if the data is already there, Srini, and it, how do you redistribute it? So you have multiple devices, and you have your tables all set up. The data is in there. You cannot use the create distributed table concurrently on in a transaction. You can use it only on one table at a time. Then, when you're talking about the create distributed table concurrently, and if you have a reference key, you have to make sure that you remove the reference keys and the foreign keys before you can do the distribution. And that's also something that Srini just mentioned. And because otherwise the updates and deletes will fail during the distribution if there are no primary keys. So you have to ensure that you have the primary key before you do anything. You have to remove the foreign keys, and you cannot run the distributed table concurrently, especially on multiple tables. And like Srini said, you need to truncate it before you do anything. So Srini, do you want to continue with exercise 3?
Sure. So one thing, so again, there's a way where you could look at the impact here, right? So um, for that, we would need an extension PG underscore CRON. So usually it comes obviously with the installation of 14 and 15. So you can just run the select star from PG extension. You will see the PG cron um, to run it, and is it timed out? So
Just
after
taking
that,
time.
I guess basically you see the command here, copy. So let me restart this for a second. Um, yeah, connection string. Let's go to this. So yeah, I'm not going to run that. We already checked before. So this is the stored procedure to actually simulate the CRON, like a cron job, right? Where you're keep populating the data here. So basically, you copy this and then create this stored procedure here in the matter of. So we're done with the procedure, and then now we are scheduling the CRON, and the cron job. So it is going to add sensor data. So it scheduled the job, right? And now you can get the job ID. So if you want, you can cancel it with that using the job ID. So to get the job ID, you run this command. So what happened?
You have to create it. It says does not exist.
Okay. Oh, yeah. So basically, we already. I have to put the number one to cancel it, so I'm
Yes.
just trying to show it there. But yeah, we don't want to run that now. So now you could actually see if it has scheduled the job. So it'll give you the start time, and then it's still running as it is showing. There's no end time to it. So now let's run this command now. Since we populate
The data.
populated the data, then we'll go through this and then show you how everything works. So now we're running the same query to figure out the devices, um, and then we are actually showing the plan, right? So when this query actually it is trying to figure out the max and min temperatures and the humidity, right? For group by device ID. That means if you have many devices, then you'll, as we talked about event table being distributed into 32 shards, then it will create 32 um, query plan shows 32 records, right? So that's what it is showing here. And so the distribution basically shows um,
Yeah, so
where are
instead of
we?
it going just to one,
Okay,
now it will go to all the shards and it'll be able
right,
to process
right,
it and bring up device. Let's say, for example, 10 devices from node 1, 10 devices from node 2, and then, it's all running parallelly. So it brings your data back together and then it's quickly
right.
aggregated at
Yeah,
the coordinated node and the data is, that's how it's faster when you distribute it on the device ID, as opposed to when on the single node, it just had to wait because it was serial.
right. So again, we are simulating that the customer workloads, and then you come out of this and then run this, run the job. Okay. So basically now later, now we are going through the steps of creating um, event concurrently we are creating event device index. So we are where are we? Did we miss a step?
Did you run the PG bench? We need to run the to simulate the
Yeah, we
traffic,
ran
right?
that.
PG bench. Oh, you ran the PG
Yeah.
bench. Okay.
So right. Yeah. So the PG URL. So now we are trying to update the primary key on events to include the distribution. So we are running
We're
this.
trying to distribute the data, create an index.
Yeah. Oh, you have to go into this and then run this. So we created the index, and now this is where the now we are updating the foreign key, right? So it's gonna take a little while to kind of update the index key, hopefully. And sometimes it says you have to run it each. transaction instead of first drop it and then add the constraint. Let's see if
Good
it is
point.
going to work. If not, I guess, yeah, let's,
Yeah. So something to remember is when you're running it,
yeah.
alter the table, drop the constraint first, and then create the add the constraint using the add constraint primary key.
So it says that you can do both at the same time. So let's drop it first and then add the constraint. So I actually encountered the same.
Yeah. Yeah. So drop it first, and then it's faster also.
Right. Now I'll copy this again. Yes, looks like we're. Do we have time or are we running out of time?
Yeah. We will. Let's just complete this quickly, Srini.
Okay. So this is probably the end of it, right? So after
Yeah.
that, you will yeah, create a reference table.
So, yeah, it's just a matter of creating the reference table, showing them how it's distributed, and then
Yeah.
truncating it on the coordinator node.
Okay. Now let's go ahead and create the reference table, device
And we're
types,
creating the
and
reference table on the device type. So that's the table that you're going to convert to a reference table.
take your time. So similarly, you can actually remove the foreign key, right? The old one with uh,
Yeah, before the distribution.
distribution, then so remove the foreign key and then start the distribution, right?
Yeah.
So we're creating a distributed table for devices, and distribution column is device ID. And now it shows that when you show the citus tables, you will end up seeing those two. Since we dropped the foreign key, then you don't see the events table in this citus table, but it'll come back when you add it, right? So now we are distributing the events table. It'll catch up a little bit. Trying to save some time. So we are creating yeah, the events table, and then when you run it, then it's going to show all three. That is
Yep.
okay. And again, you reestablish the foreign key. Reference table, something. I think the reference table thing did not work, and let me try one more time. This, not that, this one. The devices, is it showing devices? Device ID and events table is still
The
okay.
events is still as a local, so the events has not been distributed.
Right. What is it saying? Devices, and then we are copying events, and then events ID, it should. Oh, the dropping thing did not work, I guess. Oh, we forgot. Let's try this one more time.
You didn't drop the constraint?
Little little slow in. Let's wait till we get the
Yeah,
prompt and
we
we'll figure
are
out
a little
where the
over
problem.
time, so
Yeah. Okay.
we'll walk them through. But as you've seen, it's easy enough for you to copy and paste and recreate it at your end. So while Srini is working on that, I'm just going to walk you at least through the rest of it. And then, you can do the exercises when it's convenient for you. So what we're trying to do with this is show you that once you have distributed it, then you can run the same query, the outliers query that we ran, and do an explain plan, and it'll show you how much faster it was, and then the performance, how much the performance increased. And that's why you want to distribute your data, but you want to distribute it correctly. And so if you look at the specific queries, you have the same query that we've written, and then it shows you how the performance has changed, right? Look at the aggregate. It's doing your filter, it's doing your aggregates, it's doing everything, but the task is still only one, as opposed to it being 32 that's shown across. So the last thing it says, let's look at all the event IDs for device 42. What are the events that it gave us? And then it just displays to you what the 5 events are. You can also run the explain on it. Again, it shows you, see how the task was done because you did it on an event ID. The event ID is not a distributed. It is a part of the primary key, but it is not distributed. So as you can see, it had to go across all the nodes, and then it went against 32. Like I said, the default was 32. It went against all the 32 shards and then brought the data back. So it had to scan it, which obviously will take longer, right? So that's why you need to also use the device ID. So use the device ID, use the event ID, because device ID is what is sharded. It's similar to the partition concept, but the difference between partition and sharding is like little individual or partial tables, whereas partition is just partitioned in this one table, not across shards and not across nodes. So that's the difference between the partition and the shard, if anyone had that question. So since we're running out of time, we're not going to do the knowledge check, but just know that if you encounter any problems while you're doing this exercise, feel free to contact Srini or myself, and we will help you. So other than that, thank you so much for attending this session, and we hope to see you at our other Learn Live sessions. Thank you.
Thank you. Have a
Bye.
happy learning. Bye bye.